Hello, this is Mr. Pruitt, and today we're going to be talking about temperature and heat transfer. This is the first lesson in a series on basic thermodynamics. So to begin, we're going to just start with some definitions, and we haven't really talked about what thermo is. So thermodynamics are the study of the movement of heat and its relationship to energy and work. So what we're going to do is take what we already know about work and energy, and we're going to start talking about how heat and its movement or transfer in the system affects that energy and work. Our first definition today is heat. Its variable is Q, and basically heat is a form of energy that transfers among particles in a system by means of the kinetic energy of those particles. Now, if you remember when we talked about collisions and momentum and energy, we said that these particles in the system that they have these perfectly elastic collisions, that they hit each other and the momentum is perfectly conserved, and they conserve all the energy in the system as well. And so heat is just the energy that gets transferred between those particles or objects in the system. That shouldn't be confused with temperature, because temperature is basically just a measurement of the kinetic energy of the particles in the system. So it's like an average measurement of all of the energy that's contained in all of the particles in the system. And then that can't be confused with this other thing that we call internal energy. In internal energy, we're going to use the variable U. And basically, internal energy is the total amount of energy in the particles in the system. So the temperature is the average, and we use it as a measurement. The internal energy is just kind of like what we talked about when we talked about mechanical energy, when we talked about just the kinetic and the kinetic and potential energy together. The internal energy is just that total amount of energy that's contained in all those particles. And then I want to go back and look at delta, because I've gotten some questions about it recently. Remember that delta is a symbol for the change in some variable. So for an example, delta T is the change in temperature in the system, or it's the new temperature minus the beginning temperature. All right, so what's the difference between heat and temperature? This one can be kind of confusing because of the way that heat and temperature are used in everyday conversation. The distinction between them can be confusing. So this is what you need to know. Heat is always about the transfer of energy between the objects or systems. Okay? We never talk about heat is not the same thing as temperature, because when we're talking about heat, we're only talking about the energy that's transferred. Temperature, on the other hand, always refers to the amount of energy contained in the system, and it's always an average. Okay, so here's an example for you. Let's say that we have a hot iron, and your hot iron, a lot of people would say, you know, the hot iron has a high temperature, so it must have a lot of heat. But that's not necessarily true. What it has is that this hot iron has a lot of kinetic energy in its particles, and that kinetic energy we can transfer some of that energy to another object because it has because it can transfer the heat. It can give that heat away. Okay, the iron itself can't possess heat. It doesn't have the heat, but it can transfer that energy through the kinetic energy of those particles. And so we say that heat is the energy that was transferred, and the temperature is just the measurement of the amount of kinetic energy that's there. So how is heat transferred? Well, remember that heat's transferred during collisions. Every time the two particles or two objects collide, some energy is transferred from the higher energy particle to the lower energy particle. If you look at the picture up here, remember it shows you that the warmer object transfers its heat to the cooler object, and that's one of the laws of thermodynamics is that heat always flows from warm to cold. It never flows the other way. Now, there are three methods for transferring heat. There's conduction, there's convection, and there's radiation. And you've been hearing about these since probably 6th or 7th grade. So I'm going to talk about them very, very briefly over the next couple of slides, but just remember that these are our three types, and that you need to know what types, how the heat is moved in these different methods. So conduction is the transfer of heat through direct contact. Your example for this would be like a frying pan. We have a heat source underneath it. The frying pan warms up, and then it transfers the heat to the eggs because the eggs are in direct contact with the skillet. Convection is the transfer of heat through fluids, and that could be through a liquid or through a gas. We see it like above, how it's warm above a campfire, or when the earth warms up, when the sun's radiation reaches our atmosphere, or in the case of the picture to the right, we see it in fluids like magma or in water, where basically what happens is that the particles of the fluid near the heat source warm up, and then they move away from the heat source, and when they move away from the heat source, they cool off, and then they fall back down toward the heat source, and they keep repeating this cycle. So we get these convection currents where that move the heat and move the particles around. And this is the way that we transfer energy whenever we have a fluid environment. And our final way is by radiation. Radiation is the transfer of energy by electromagnetic waves. Radiation is unique to the way that we do this because radiation can transfer heat without the use of a medium. Conduction, remember, requires usually it requires a solid, and it's through the direct contact, and convection requires fluid mediums. But radiation can transfer energy, can transfer heat through a vacuum, through nothing. So radiation is a little bit unique that way. Generally, we say that radiation occurs alongside conduction and convection, but it's normally we normally identify it when the other two can't explain the energy transfer. Like for a long time, people tried to explain how heat got from the sun to the earth. And the truth is that because it travels along these electromagnetic waves, it can travel through the vacuum. But for a long time, people thought that it needed a medium, and so they spent the equivalent of billions and billions of dollars trying to research a thing called the ether that really didn't exist. Now, I do want to direct your attention to the picture of the campfire. The campfire is a really good example of radiation, because when you're standing out to the side of this campfire, you can feel the heat and you can see the light. That's radiation. But if you were to put your hands over the top of the campfire up here, you would see it would feel warmer, and that's because there's two things going on over the top of that campfire. You're getting radiation off of the campfire, but you're also getting convection, because as it warms up the air particles above it, they become more energetic and they move up, and it transfers the heat through the air through convection. So you actually have two things going on there. Anyway, I hope that this helps you, gets you started on what we need for tomorrow. Make sure that you're ready and you have your notes for class tomorrow, and I will see you then. Bye.